Okay. Reminder, if you have accommodations, please make sure you confirm them with me. Stars are just a heads up where you need extra good notes. In some cases, I think it might be tough to get all the details out of the book. In some cases, students make mistakes in the long term. Some of these show up later in the year or on the AP exam. Please look up. The stars have nothing to do with what goes on the exam. On the exam, I can tell you exactly how I distribute the content. A total 1/3 of the stuff on the test is stuff directly from my lecture notes, like where I know in class we added stuff. 1/3 of it is stuff that you did in the book with the homework guidance, and I never brought it up in class. So sometimes a high school student will ask me, like, hey, what's number 33? And I'm like, oh, I wasn't going to talk about that, but let me show you. But if somebody doesn't ask me, I never brought that up in class. And then 1/3 of the stuff on the test is things that are from other sources, like the movie, like the reader. A lot of this will overlap or reinforce other homework. But like field trip stuff, that would fall into that category. And right about now, we're starting to kind of crank up the exams a little bit. So Unit 1 was pretty mellow. Unit 2 was not too bad. Unit 3 is starting to get some new stuff. And in the next units, it becomes really critical that you not just show up for class. That's not enough. Especially Unit 4 to the end of the year, we're going to get to that part where, you know, 1/3 of your grade is going to be straight out of the book without me saying anything about it. That's, in some cases, very intimidating. Okay. The stars. I'll go in the order that they appear in the study guide. Primary, secondary production, facilitation, interference, different types of diversity, the founder effect, the biome tour vocab, and we are going to finish the biomes tour today. The different extinction terms, like local, global, functional, punctuated. All the vocab in the reading packet. Study goal number 2, number 4, number 5, 7, 12, 13, 15, 18, 19, 21, 23, and on number 23, that's probably the best place to insert your extinction lecture, the endangered species lecture notes. Those go with number 23. Start for 25, 27, 28. $30, $31, $35 kind of showed up elsewhere, but $35. Oh crap, might be, I did not mean 35, I meant 30, sorry. I meant 34, excuse me. I heard you all flip your papers and I realized I messed up. I meant 34, excuse me. So that one showed up elsewhere, but 34. 38, 39, 40. And we're skipping 3.5 because I didn't get to show the second movie. Since you have your whole packet out, can we confirm that there's nothing left to talk about in 3.1 or in 3.3, this would be a fine time for you to say, hey, you didn't say, or you said you'd come back. All right. Yeah.
Do you just go over punctuated extinctions?
Yeah, those are just mass extinctions. That's another way to say when a bunch of things go extinct in a short period of time. Anything else that you wanted in 3.1 or in 3.3? Then let's finish the tour of the biomes. I believe that was in assignment 3.2, correct? Study over team? There's like 10, 12 of those.
10, 12 more?
There's like 10 or 12 more biomes. And I mentioned that because I'm going to have to go really fast just to cover them. Here's where I've gone as a teacher. I used to have a 1-week biomes tour where I would go over these slides for like 4 or 5 hours of class time. I've been shrinking this down because more and more students have a bio background. But it's tough for me to explain this. Like, the College Board will always make an environmental problem in some biome. So they need you to know, like, oh, if it's like in a deciduous forest, there's going to be leaves falling everywhere. And I don't know, some of you are really familiar with these, or you're a naturalist, or you've traveled a lot, or you're just into the map, and some of you have no idea, so I really don't know how much to lecture. I'm going to try to just drop the key terms, like word, 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 word. So I think you should probably write a lot. Did we already talk about deciduous forest?
Yeah.
Yeah.
This was on the holiday previously known as Columbus Day.
We're at the temperate rainforest now.
So we're at temperate rainforest. Sweet. What?
Yeah.
Oh, roll over the chaparral. So watch. Here's how much I want to say, for example. Deciduous, most of the city's hardwoods. And Pacific Northwest, tons of rain, giant conifers. And like a super tiny, obscure southern US yellow pine forest. It's very dry. And the one that you live in, shrubland, chaparral, Mediterranean. Chaparral means dwarf forest. This biome shows up in 5 parts of the planet. They're all called Mediterranean regions, and they all have dwarf trees, little miniature trees. If you look on this map, on the west coast of all the continents, around 35 degrees in latitude, there's like a little coastal strip of red. See that? It looks kind of like a brownish red. It's very dark. And notice what a crazy coincidence. Only on the west coast, pow, 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 only at 35 degrees, north or south. You get the 5 Mediterranean zones. People say that the climate is Mediterranean, but the biome is chaparral or dwarf scrub or whatever. Thanks, dude. Both here? Yeah, they are. And I gave Roxy a bunch of slips because I forgot to give the kids in period 1 their papers. So I've got 3 kids who didn't do this during period 1.
Okay.
Because I effed up. It's not the kids' fault.
Okay. I'm just a messenger.
Do you know who writes these? Like who
The assistant principal's office.
So we'll get the slips back.
Yeah.
Or should I give them to you? What's better?
Does she have them right now?
Yes.
So I can find out there.
So those 3 that Roxy just gave you are the ones that I messed up.
Okay. I'll find out what they're for you. Thank you.
Okay, back in. Fella?
Oh.
They want your photo.
No, but I took my photo. I have my ID.
You have your ID?
Yeah.
Seems to me like you don't need to go.
Right?
Alright.
Is it rude?
Is it rude?
That's why you want it.
You're worried about being rude to some random photographer guy?
Yeah.
You're so cute. I would totally ignore that. I should never think about it. Alright. All these Mediterranean zones have a very unique climate trend. These are exceedingly long, dry summers. All of you who grew up in Santa Barbara will be shocked by something the whole world knows except you. All over the world it rains in summer. Like, all over the world, wherever else you go, it rains in the summer. Grassland, Florida, Sierra Nevada mountains, whatever you want, it rains in the summer. And then here in Santa Barbara, that's like, what? It's not possible, because it like never rains here. We go like 9, sometimes 10 months between rains. That gives us the longest dry spell of any place on Earth as a biome. There's only one place on the planet with longer dry periods. That's a very unique, special desert in the high elevation above Peru or something. So we have these really long dry sections. And then our wet season is not a season of rainfall, it just includes a couple big rains. That's true of all Mediterranean, so you have to know that. Extended dry, super hot, 9 months. And then a 3-month window with 2 or 3 fat storms. I mean, some parts of the world you always keep your rain jacket around. Some parts of the world it rains every day. Some parts of the world it rains most days for 6 months. Santa Barbara's weird, like in the rainy season, quote unquote, you'll whip out your rain jacket and wear it 4 days. Yeah, and then like you'll outgrow it or lose it or your dog will eat it. And it's like, great, you need another rain jacket. Like, this is a really weird climate. So our plants have this really difficult to explain set of adaptations. All these plants are miserable dwarves. They have reduced green tissue. They're very dense, slow growing, and low to the ground. They're just like, ugh, God, I hate this, it's horrible. Like, look at those plants. They look like they're happy to be alive. They're all like, ugh, God. Like, that is pretty much the accommodation. They're like covered in wax so they won't dry out. Instead of having like leaves, they have like leaves. Instead of like growing, they just like, ugh, God. Like they make these like really dense, thin, scruffy growth where they're just like, yeah, it sucks. And they just tough it out. They don't even get that thing where they get to grow in the rainy season or whatever. They just go like, oh God, thank God I got a little rain. It'll be like, blip, blip, and like pop out a couple of leaves. Or like, oh, and they like throw out a flower. And then they make like gazillions of seeds because the chances of one of those seeds making it is right around no effing chance. There's like no soil here. Because like things don't like sit around and decompose because like nothing can live because it's just like the driest desert. Like in other parts of the world, if you have to poop, you just walk off the trail and you dig a little hole. We call it a cat hole. And you take a poop in a hole. But if you've ever been stuck in the backcountry and you have to poop, you just like throw it at someone because you never get a hole in the ground. No, the struggle is real. We live in a really unique climate. Look, this is where you live, so you know. We have extremely long, dry summer and extremely wet, rare storms. We've got a longer, drier, hot period than pretty much anywhere on the planet. So all these plants are just suffering. Like these are pretty much the hardiest plants. Do you know that if you have potted cactus in Santa Barbara, you have to water it? Like think about what that means. Everybody's like, oh, you know, I'll get some like desert plants. Like, good luck. It rains all the time in the desert. They're little tiny rains, but it rains, you know, 200 times in a year, 150 times in a year. Yeah.
What is like the Central Valley? Is that the same kind of deal we got?
Parts of the Central Valley, but most of that is an arid grassland. Because it's a coastal influence, parts of the valley get a ton of water, like the San Francisco Bay Delta brings in marine layer toward like the northern half of the Central Valley. Southern half of the Central Valley is pushing toward desert aridness. The southern part of the Imperial Valley is one of the driest parts of the planet. A lot of the planet gets less rain than the Sahara. Everybody like says like, oh, it's like as bad as the Sahara. Like, no, actually, a lot of stuff is worse. The Imperial Valley gets less rainfall than the Sahara. Which, of course, we do too. We get less than the Sahara also. We have this really high density. We make a ton of seeds here. Our plants are coated in wax, so they won't dry out. That's worth knowing. So it makes them really flammable. Like, look, this totally looks like Santa Barbara, right? Like, as wet as it gets over in Halama, like, that's a view from near the gun range. Like, that looks pretty standard Santa Barbara style. Like, you know, a little front country photo. Here's like a big expansive front country photo. Do you all notice how gray that looks? That's because waxy leaves, when they heat up, they get sticky like a candle in the sun. And so they trap dust. Like our plants are dirty, so they're just like, ah! It's like coated in wax so they won't dry out. It's really important to point out that we are what's called a fire renewal community. Fire renewal communities are environments that cycle nutrients from fire. So fire is a good thing. It renews. All those plants have all their nutrients locked down. The soil sucks here because there's no soil, because there's no moisture. So the plants keep all the nutrients in storage, and when they light on fire, those ashes are like a big hit of nutrients. So you can see the poppies all flowering the year after. They got a bunch of nutrients from that other bush burning down. And I don't know if any of you had a chance to see this, but after the tea fire, the flowers were amazing for 1 or 2 years. After the cedar fire, the flowers were amazing for 1 or 2 years. And the places that still have soil after the Thomas fire, they're going to go off this spring. because our environment is adapted to fire. With the degree of aridness you build in these settings, with all that plant density, the only things that cycle nutrients are fire. It's also interesting to note that this is a really heavily endangered system. Humans love living here. The Oprah Winfreys of the Mediterranean and wealthy South Americans have a house in the Chile coast, and wealthy Africans have their nice houses in that little part of South Africa, and all over the South Pacific, people have fancy houses in that part of Australia. These are like the place to live if you're a human, because you know the temperature, right? Flip-flops, trunks, and a t-shirt, like 320 days a year in Santa Barbara. Like, you might need to put on a sweatshirt every now and then, but... So this is one of the rarest landscapes. Like, mile by mile, this is one of the rarest biomes. Very, very, very little Mediterranean remains unused by humans. This is why we get so pissed off about development on the coast here. Like, a lot of us that grew up here were kind of spoiled. Like, whatever, man, it's just the Galita coast. But, like, yeah.
How high up the coast is our little section of coastal Mediterranean go?
The funny thing about biomes is, like, if you change the definition, you change the map. Right? Like, if you have wet chaparral, then that goes up almost to San Francisco. Right? Because, like, if you think of Monterey, Big Sur, like, that's pretty chaparral, it just gets more rain than we do. But if you're thinking of, like, the dry Mediterranean, then that pretty much goes roughly up to the Ranch, Coho, Government Point, like right at the actual tip of Point, Conception. Little bits like stretch into like the Santa Ynez Basin, like Lompoc, so stuff. But already up there, you're starting to get more rain. So it really depends on your definition. Temperate grassland is the orange stuff. Your notes have to include a few things about grassland. First of all, this is the world's bread basket. This is where everybody grows their food. And I can give you an explanation that is circular, and then we'll come back to that. So get ready for this. Watch. Watch. 4 distinct seasons, but it rains in all of them. So summer is different from spring. Like, they feel different. Like, really hot, really nice, really cold, really nice. Like, there's 4 distinct seasons, but they all have rain. So this favors grasses. There's like the spring grasses, and then they all dry out, and then there's the summer grasses, and then they all dry out. Because you have like a little rainy season every couple of months, then that's going to favor grasses that are specific because they grow really fast. You understand what I mean by that? Like, grasses go from seed to sprouting in like 3 months. So you go like, whoop, and then like, sorry, from sprouting to seed in like 3 months. So like sprout and then drop their seeds, and then they sprout and drop. So watch. Spring grasses die and fall over, the summer grasses die and fall over, then the fall grasses, and then they die and fall over. So every 3 months you're getting a layer of compost. You understand what I mean by that? So grassland, because there's 4 sets per year, has the world's deepest, best soil. And it rains every season. That's really good for farming, right? Like good dirt and lots of rain. So this is the world's breadbasket. 4 rainy seasons means grasses, means the world's deepest topsoil. And by the way, which country has the most orange? That's pretty much the secret to America's glory right there. Like, this is why we were the chosen colony, and this is why we were able to really leverage our landscape through a couple of wars that would have been more devastating to other countries. And this is, there's a lot of really fundamental historic superiority that comes from our big old breadbasket. Like, look at how many people depend on South Africa's farm productivity, or how many people across Eurasia depend on that little strip of orange. So remember, there's distinct seasons with distinct weather, and they always have some rain and some dying grass. So you get super deep soils. Like, I know you guys don't know a lot about growing food and stuff, but I've been growing food for most of my life, and I know dirt, and that's good dirt. Like, the dirt in this photo, like, holy mackerel. Like, if you had that dirt in your yard, like, dude, that's such good dirt. Like, the color and texture and shape of that soil, like, that is really good dirt. That's like premium. That's the good stuff. That's why, by the way, it's such productive, since we've been talking about extinction and endangered species and stuff. We are the world's first nation to use intentional extinction as a weapon of war.
Oh yeah, they killed all the bison, right, for the Native Americans, so they die off or move.
Yeah. I'm really bad about this. I don't remember if it's Navajo or Apache, or there's some overlap among Navajo and Apache, and I'm like a really bad source for this information.
I think it was both, and didn't they do it to move them to the reservations?
And I'm a physical anthropologist, but I had to take a cultural anthro class, so I heard this stuff and I forget which one I'm talking about. But I think it was the Apache were really good at fighting American soldiers because they had horses from Spain. So when Spain came to Mexico, they lost a bunch of horses to the Apaches somewhere in the American South. And then when United States Europeans or English Europeans were spreading westward and manifesting all that destiny, the Apache could like shoot like 5 arrows in the time it took an American soldier to load a musket. The American soldier had to kneel down to do that. The Apache could shoot those 5 arrows from a racing horse. So you can imagine the military superiority, right? They could get off 5 accurate shots on from a moving target on a stationary target that could shoot back once. So we couldn't beat them, so we starved them. Starving your opponent is common in warfare. But we got so good at it that we drove their food to extinction. Technically, a couple of buffalo survived in remote populations outside the United States, and as set pieces in like western United States, like California, San Francisco, Catalina Island has a few little buffalo as like props for movies and stuff. But we were the first nation to use an intentional extermination of a species as a weapon of warfare. I find that to be really interesting. We paid hunters to shoot them from trains, so the Apache would starve and we could force them into other parts of the United States. Anybody else find that interesting? I don't know about you. To me, that's a unique moment in U.S. history. I find that to be sort of. Were you asking the question or you saying something?
They were also driven extinct because of the Apache-like tribes. They have horses, so they way overhunted them.
They rushed them in herds off cliffs. They didn't just have the hunting superiority of a horse versus a buffalo, but they didn't target single buffalo. They would herd up like 500 buffalo with 20 horses and then drive them off the cliff and just butcher a couple of the ones on top. And so in many canyons, you'll find these middens of decomposed buffalo remains. There's this false notion of Native Americans as like noble savages that were in like perfect harmony with God and land or whatever, and like there was good guys and bad guys and stupid mistakes throughout the history of humanity, including the Apache. Yeah, and so you're absolutely right that they were already kind of hammered compared to the Pleistocene era. Absolutely. Yeah.
Don't they do that with lemmings also?
I have heard that lemmings don't run off cliffs. That whole thing is like a misunderstanding, and like they do fear predators, and so predators will hunt them on a cliff. So where there's a whole bunch of lemmings, like a bird will swoop down, and all these lemmings will just run away. So half of them run one way and half fall off the mountain. But I've heard that the whole lemming phenomena is somehow dramatized. Yeah.
Wasn't it made by Disney to have region characteristic?
Neat. I would love to talk more about this, but we're racing the clock. You're going to be really annoyed with me at the end of our period, so I'm going to try to focus. Most of the world's grassland is our farms. It's really important to point out that this is basically farm. Okay. Through the tropics, tropical rainforest is the darkest green along the equator there. You can see there's 3 big chunks: South America, Central Africa, and Asia. Tropical rainforest is exactly what it sounds like, tropical and rain. And because it's on the equator, every day is the exact same length. So there's no seasons. That was a whole bunch of facts. Do you all understand that on the equator every day is equal? That's what's equated by the equator. You know you're on the equator when yesterday was 12 hours and tomorrow will be 12 hours. That's how you have found the equator. You just need to watch. Because every day is precisely the same length, there's no variation in sunlight, so there's no variation in temperature, so there's no seasons. That is perfect consistency. Is consistency better for a generalist or a specialist?
Specialist.
So imagine in the tropical rainforest, you have perfect conditions for growth that is perfectly consistent. So you have extreme diversity. And here's the last really surprising detail about the tropical rainforest. Like, let me show you a picture. Would you guess that's really good dirt or really bad dirt? What? Doesn't it look like that must be spectacular dirt? But here's the funny thing. Every one of these plants lives in the perfect climate for plant growth. They grow all day, every day, because tomorrow's perfect too. There's no down season. These plants have no rest. They're just sucking stuff out of the dirt. And with all that heat and all that humidity, stuff decomposes so fast. Like a dead body turns to fertilizer in like 4 days. So guess what? There's nothing left in the dirt. These are some of the worst soils on the planet. They're perfectly depleted and totally leached soils. Whenever something decomposes on the soil, the plant's already got the heat and the rain and the sun, so they're just waiting for the feed. All these plants will just stall, and then like something will die and they go like, it'll grow again. Check this out. Always warm, rainy, sunny. Ideal for plant growth. You get this layering because of competition for light. There's no water storage. A zillion diverse little specialized niches. And all the nutrients are in the plants, not in the soil. By the way, all the nutrients are in the plants, not the soil. That's why we have to burn down the forest so that we can grow stuff there. Slash and burn agriculture. The whole thing when people burn down the forest to like grow your corn or whatever. Okie dokie. Check it out. Bad dirt. Imagine if something decomposes, everybody's ready to grow. Check out the layering. Subterranean, terrestrial, understory, middle story, top story, and emergent over the top story. There's something growing. Look at the diversity. You can see how different all the plants are. If I show you a picture of Tuolumne Meadows, it's one dominant tree species. But look at how many tree species you have in that photo. Because of that specialization. There's one tree that's good at this and one tree that's good at that. Look at the density. Stuff grows on stuff that's parasitizing other stuff that's growing on top of stuff. With all that water, any nutrient on the ground, if it doesn't get soaked up, will leach out. Crazy diversity, specialized all sorts of stuff. I've got some good rainforest stories if y'all ever get bored. We should point out that humans do everything except logging here. There's not a lot of wood that's worth carrying through all that gnarly forest. Most of that wood is all like woven together. And there's all this like spongy, foamy vines and parasites and bugs in it. It's not easy to drag lumber out of here. So it's all about the ranching and the farming and the mines. It's not really about logging. We do not do deforestation for trees. There's probably a lot of this biome left because humans don't really like living there. It's scary. Everything wants to eat you in this biome. I'm going to skip this one, monsoonal forest, and I'll just say really quickly about a tropical savanna. It's everything you saw about grassland, but in the tropics. So you have less variation, less seasons, but still rainfall and grasses. So it's like grassland, but it's in the tropics. Did you already send for everybody else? Tropical savanna is that salmon-y color, that pink stuff. And in Africa, that's where all those big herbivores live. Imagine it's a grassland, but it's in the tropics. So like hella rain, hella good dirt means hella big stuff. The elephants and the zebras and the wildebeest and all the lions and the hyenas and stuff, that's savanna. Man, I wish we could talk about elephants and cheetahs. Do you all know that the worst period for elephant poaching is like basically right now? Like the world's worst conditions for elephants are like 2017, 2018. Because Africa's running out of food because climate change, they're not getting surpluses. So the average African is getting poorer. And with food shortages, they're like, well, I guess it's time to go shoot that one elephant that I know is protected, but I gotta feed my kids. So elephant poaching is at an all-time high right now, at the same time that a lot of Asian buyers are becoming more wealthy. They're buying more ivory. It's kind of shocking. Like, elephant poaching was a thing of the 70s and 80s, but it just highlighted, like, just like flared up 2015, 16, 17, and 18 because of climate change. All right, this is a pretty intact part of the world. It's kind of scary, not a ton of development, not a lot of humans. This might be the place where we put more farms. Like if we really had to stretch to feed humans, it might be the savannah. Two biomes left and then we're done. Desert is the world's largest biome. Look at all that white on the screen. We have more desert than anything else. You know, it's kind of crazy that when our planet is cooler, a lot of that desert turns to grassland and savanna. But as our planet gets hotter, this biome keeps growing. Sort of an interesting fact. The single biggest misunderstanding about desert. Yeah, it's kind of dry, but it rains pretty often, just little tiny bits. So like Santa Barbara will get like 30 inches of rain a year over like 6 days. The desert will get like, okay, less, 20 inches of rain, but spread out over like 200 days. Of just like a little, pss, pss, like little tiny drizzles every day. That's why you gotta water your cactus in Santa Barbara. Big misunderstanding about the desert. Yeah, it's really hot, but anybody been to the desert at night? It's cold as F. What desert has is, yes, low overall rainfall, but extreme daily temperature swings. I've spent a little time in the desert. I was in Anza Borrego once. When I woke up with a frozen water bottle, it got 108 degrees in the middle of the day, and that night it was like 15 degrees below freezing. That's extreme temperature variation. That's why it's so hostile to life. You ever seen those like nomads on the Sahara that like wrap themselves up in like a whole bunch of layers of fabric? They need the insulation to keep their bodies cool during the day, and then they need all that insulation to stay warm during the night. Like if you're naked in the desert, you cook and then you freeze. When I say desert, everybody thinks of sand dunes. But just so you know, only about 5–6% of the world's desert is sand dunes. Most of the world's desert is not that vision that people see of the sand dunes, but it's like this, vegetated. Like if you drive down to Mexico, this is the desert. And if you drive through Palm Springs, like it looks more like that. You go to like Joshua Tree or Anza Borrego or whatever, it's not sand dunes. All the stuff grows. But can anybody imagine how a seed could possibly get started growing in sand? Like the sand is moving and the wind takes it away and the water pours right through. How do you sprout seeds in sand? A little bit of magic. The stuff in the foreground of this photograph. Vocab, please look at the board. It's called biological soil crust. And I'm sorry about this unfortunate reality of science, but there's like 1,000 ways to say biological soil crust. There's like cryptogamic soil crust and mineral crystalline matrix soil crust and like 15 gazillion other ways to say it. But the secret is it's a crust on the sand. It's like a foamy, semi-rigid layer on top of the sand. I have such an obscure reference, but every year I find that high school kids know exactly what I'm talking about. How many of you have seen that it's like a brick of green foam that you stick flowers into to put them inside of a vase? How many of you have seen that? Probably in some old lady's closet or in like some old lady's laundry room or something. Like, I am shocked that we've all seen this, because how many of you have spent a day arranging flowers in that green foam? So like, we're clearly the minority, but still everybody has seen this stuff. If you've seen it, you know what I'm talking about. You can like press your thumb into it, and then like it just disappears or turns to dust. Super fragile. You know what I'm talking about, right? Like you like touch it and it's just like, oh my god, it's just like dust. Like you pay like $3 for a sponge, you just go like, and it's gone. That's what the soil feels like. And it takes like 10,000 years to form. Have you all seen like water evaporates from a glass and leaves like a little white ring on the edge? You know what I'm talking about? Like the salt in the water will dry out and leave like a little bit of like crystalline structure. It's like, you can like rub your finger on it, it feels kind of gritty and dusty. Now imagine that happening on sand for like 10,000 years. So every day it rains a teeny little bit and minerals dissolve out of rocks and they pour across the surface. Just like constant like mineralizing crystals of salt. So biological salt crust, repeated evaporation of water. It's a mineral matrix. And it's the secret to life in the desert. See in the background of my photo how there's sand dunes? And then there's like a couple of little bushes? And they're kind of limiting the movement of the sand? And then in the foreground, there's that foam that those bushes were anchored in. Here's what's crazy. If you go to this desert and you walk on that foam, it'll turn to a sand dune. Because plants can't grow in that kind of sand. Like sand dunes are just sand dunes forever until water keeps moving over it and they start to make that crust. And now the seeds will stick and they'll sprout and it'll hold water because it's like foam. Neat thing about the desert, right? Anybody else find this interesting? I think it's kind of pretty cool. You know there's places in the American Southwest where you can see footprints in this sand from like the wagon trains. And like the place where they tested the first tank in like 1912 or whatever, like those tracks are still in the ground. Because the crust is so delicate that you drive a tank across it and there's just like perfect little notches in the crust. So all those bros that go to like moto race in the desert, they're ruining the desert. Like I have a motorcycle and I want to go race it, but if you mess up this crust, it's like over. Because now plants can't grow in that dirt. It takes like a bazillion years to make the crust again. Yeah?
Is this different from like the Bonneville salt flats?
Kind of yes, kind of no. So they both result from evaporation of water leaving behind salt. That's the same. But salt flats are just solid salt. So you keep filling a basin with water and the water evaporates leaving just the salt. So it's a dried out ocean. Mm-hmm. And at the Bonneville salt flats, you have to dig, I think, 450 feet until you hit actual dirt. It's just salt on salt on salt. If you kept going with this and water couldn't escape, then the salt would accumulate and eventually make a salt flat. They're very different extremes of the same concept. Evaporation leaves behind salts. Yeah?
If the crust is gone but the plant is still there, will the plant be able to survive?
Kind of depends. It's a little situational. So like how shifty the soil is around the plant. So in many places it's kind of rocky where the salt accumulates anyway. So like sometimes those plants will be fine. But if it was previously just sand dune and then you lose the crust, most of that sand will move so much that the plant just kind of gets tumbleweeded into nothingness. It really depends on the spot. You all know about the plants, you know, they don't have leaves. So they can stay alive with just a teeny little bit of water. Do you all know that a cactus is a photosynthetic trunk with no leaves? It's like the trunk of the tree does the photosynthesis. So you better not be cell phoning. I'll throw my shoe at you. That's what my grandmother used to discipline her children. She would throw flip-flops.
My kindergarten teacher did that to me.
Rad. I'll bet you had it coming.
She took my shoe off and like threw it at me.
Your own shoe?
I was like,
dang.
Yeah.
That's a whooping.
Yeah.
All right. Nocturnal animals avoid avoid the heat, you know. Water storage. You can drink these ants. They're called honey ants. Pop their butts and then drink that sugar water. That's actually kind of real. Mostly intact because humans die there. And there's nothing to get there. Desert is definitely the winning biome. Of all the biomes, desert is definitely winning. Aside from a few mines and stuff, petroleum, we don't really mess with the desert. We drill there, add water and grow dates. There's just one biome left to talk about, and I'm going to go really fast so we can move on to other stuff. Wetlands are kind of terrestrial, but they're land that is sometimes covered in water. Land sometimes covered in water, you know, like wetlands. Land that is sometimes covered in water. So that's land that's sometimes covered in water. If you went on the field trip, you saw a bunch of land sometimes covered in water. This can be sometimes covered because it rains and it pools up, or it can be sometimes covered because salt water level rises at high tide. Those are all wetlands. And think about how productive they are. They got all the water, they got all the nutrients, they've got sediment, they've got sunlight, it's warm. Because the water is shallow. That is hyper productive. Remember the lagoon? How many of you were on the field trip? Lagoon's the perfect example. Hyper productive. And you know, if you're growing a lot of stuff, that's a lot of food for other stuff. So primary productivity, ... secondary productivity. So the habitat value is obvious. Check that out. Coastal, freshwater, saltwater, shallow or deep, warm or cold. These are some of the most important habitats on the planet. And get ready for the last bit of notes before we put away the biome stuff. 3 things that are special about wetlands. Number 1, it's called the nursery effect. That's where all the big fish go to make their babies. So the babies can eat all the bugs and little fish. Nursery effect. It's like abandoning your child at the supermarket. Kind of a good idea. It's the place where children are most often lost. And I wonder if this isn't like a nursery effect for humans. Some dad's all tired and like, ugh, gotta take my brat kid to the supermarket and buy groceries.
And then just casually leave them behind and drive away.
Like halibut in the estuary. They're like, nah, you know what, you'll be fine. Go to aisle 6.
Okay.
Not speaking from experience or anything. But the nursery effect, you know, like leaving your child at the supermarket. And number 2, think about how important this is for birds. There's food and there's water and it's super productive. So you saw the bird diversity at the lagoon. You know this if you went on the field trip. And otherwise you can still imagine that's a nice place to be a duck. And this other one, number 3, that's for humans. It's called the sponge effect. Wetlands work like a big sponge on the landscape. Watch me. I wash dishes in a 2-basin sink. I've got my nasty water with like the soap and the sponge and like food disposal for all the gunk. And then I've got my rinse, which is usually pretty clear water, and then I put it in the dryer. And imagine, I pull the drain on both of them, and one of them had the sponge in it, so it goes whoop, and it blocks the drain. while the other one didn't have a sponge, so that water just goes, whoosh, it's gone. Let's think about what that sponge does, because that's what wetlands do. Because wetlands absorb water, they're like a sponge. Quinn, you better not be doing other work in this class, working off your cell phone.
No. It's been this fun.
That doesn't answer my question. Why are you working off your cell phone?
This class.
Doing work, you mean, or copying somebody else's homework from another cell phone? You might be better on the exam if you focus on the stuff in class instead of getting almost no
No,
points on
also
the
like
late copy
multitasking
homework.
and writing down notes at the same time.
We can argue about this later. Stop. Think about what happens to the water with that sponge. First of all, like in the landscape sponge effect wetlands, that sponge will filter the water. It'll slow the rate so it avoids flooding. And then it'll pour out little bits of water over time so it recharges the groundwater. Watch. The bird thing, the nursery thing, and sponge, like a sponge in the sink. You prevent the flooding. You filter and clean the water. And you allow water to seep into the ground longer. That recharges groundwater supplies. We call that the sponge effect. I hope you remember the analogy of the sponge, but wetlands are probably the single most critical biome. Like globally, there's like the single most important thing because they're key to fish, they're key to plants, they're key to water quality, they're key to air quality, they affect humans, they affect our drinking water, they affect our pollution. This is like the #1 most important biome, I think. It's the one that we do the most restoration for. We spend the most money restoring wetlands. If I'm not mistaken, we finished 3.1 like 2 weeks ago because it was pretty mellow. And then we finished 3.3 a while ago. And then I think this was everything we had left on 3.2, unless you want to ask me something. We're done with the biomes. Yeah?
I want to ask about the factors that increase or decrease biodiversity, number 13.
So productivity and consistency. If it's consistent, you can specialize, and if it's productive, you can have more niches. You can divide it into more niches. Okay, if we're done with 3.2, then all we have left is like 2 articles from the reader. Did we already talk about catch shares in this class? Then take out 3.4. I'm just going to talk about 2 study goals. Warning number 1, I put a lot of stuff on your exam that we don't talk about in class. There's a lot of articles in the reader. Don't say I didn't warn you. Warning number 2, topic number 2. I would like to talk about catch shares and the connectivity movement. Let's start, who knows what it means to own a share of Apple? Yeah.
You have partial ownership of the corporation.
So what's that worth?
The percentage that you bought.
The percentage that I bought of what?
It's like investing.
Of
You're
equity.
giving them money.
Equity in what? In the company?
Yeah.
So how does that price change over time? Why do we follow the stock market?
The value of the company changes.
So if the company is doing a better job, it's worth more, and my percentage is bigger. Everybody understands this idea? All right. There's two ways to manage fisheries. There's what we call the open season method. That's old school. If you've seen The Deadliest Catch, Alaska Crab Fishery TV show, then you know what I mean about an open season. I'll describe. Season opens, all the fishermen rush out there, they get as many crabs as possible, as quickly as possible, because the state is keeping track of how many crabs, and pretty soon the state's going to go stop. And everybody has to stop fishing. Open season. So you open it one day, keep track, and then you stop everybody from fishing. This has 3 problems. You have to write these down. Open season has 3 problems. Dangerous for fishermen because they're all in a hurry. They go out in bad conditions. Super dangerous for fishermen. Problem number 2 of open season. Everybody's in a hurry to get the crabs no matter what the cost, because you only get a few days to fish. So they'll do whatever they got to do to get crabs. And problem number 3.
Wait, what would you say what problem number 2 is?
They do whatever to get crabs.
Yeah, so it's high impact. You could say it's a very high impact fishery. Problem number 3, because everybody's fishing at the same time, the price for the crabs falls through the floor. There's either no crabs, or everybody's sick of crabs, or they're gone again. So it's called an unstable market. This is problem number 3. Now, in the United States, most commercial fisheries are in open season management. That's also the global trend. But a few years ago, people came up with a new idea called a catch share. Like a catcher catches a ball, or a fisherman catches a fish, share. Here's how that works. Instead of everybody go, 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 and stop, it works like this. We know we're only going to take 1,000 crabs this year, so you can have a quarter of the crabs, you can have a quarter of the crabs, you can have a quarter, and you can have a quarter. They get 25% of the catch, like a stock market. Now, if those crabs do better and better every year, you've got 25% of 5,000, 10,000, 20,000, 100,000 crabs. So like Apple doing well, there's an incentive for those crabs in the ocean to grow. You know what I mean by this? This is why shareholders keep track of the company and complain that the company's making stupid mistakes. Yeah?
How could anyone regulate that, though?
Well, there's a bunch of ways, and it's actually, these are all regulated fisheries. Like if you cheat, you cheat. You can cheat the first one, you can cheat the second one. Right? Like cheating is always possible, it's always illegal, you always get busted, and there's always a regulation challenge.
Yeah, but like even dividing would be really difficult.
Well, they've all got an individual quota instead of a fishery quota. So in Alaska, there's a number, and it's like every man for themselves, just get the most you can, good luck. And here, it's kind of like a socialist thing, where like we're just going to divide this evenly, so people are like, but I'm a better fisherman, and she still gets the same amount. And you can imagine that there's some complaint about that. But there are some benefits. For one thing, there's no hurry, so it's safer for the fishermen. Because you know you're going to get your quarter. Like she can't take more than a quarter, so I'm still going to get my quarter. Who cares? So there's safer for the fishermen. Number 2 is probably the most important benefit. There's an incentive to conserve crabs. Like I'm not going to use dynamite. I'm going to put the babies back, and I'm going to give them a little extra food so there's more crabs next year. So there's an incentive to take care of the resource. And this is the part where really, this is the big benefit. Like you turn every fisherman into an investor in crabs. Benefit number 3, if you know that she can only take a quarter, I'll just wait for her to finish fishing, and then I'll take my turn, and you stretch out the harvest so it's a more stable price and fishermen make more money. You already know how many crabs they're going to be caught. You're going to space that out so it's not like a boom and bust market. Does this make sense to everybody? Final thing that I wanted to talk about is study goal number 31, connectivity. And I can explain this in like 5 words, and it's already an article in your reader, so you should be able to get it. Connectivity is connecting little pockets of protected land so that they don't become isolated. Protected land. You know, right now, if you go to Yellowstone, there's all these happy grizzly bears that can't leave. So like their genes are separate from the grizzly bears in Canada. They can't exchange genes. So it's like they're on 2 separate islands. But if you can connect them with like bridges over freeways and like tunnels under cities or whatever, then those grizzly bears are genetically continuous. They interbreed, it's one population, it's healthier for them in the long term. Anybody want to ask me anything about connectivity?
So it benefits genetic variation?
Yeah, that's right. It maintains genetic diversity. We call that genetic continuity, but you could probably say that without the word. Oh man, if we didn't have to look at these exams, I'd have 15 more minutes, but anybody want to ask me anything before we switch gears again? These are all the study goals that I had planned to talk about, so we made it. We just don't have as much time as I would like right now. We've got about 12 minutes. I want everybody to remember that when you leave, I need to get all the test stuff back up at the front.
I'm not sure how it could be like,
Yeah, there's a lot of terms for it, like you need to visualize, take quotas. ITP. Yeah.
Do bigger companies get like bigger shares? Like,
You can sell it like a stock market, so some guy can buy up all the lobster and then control the market. It's an unfortunate monopoly question that's kind of a regulation question. And so then like there are supposed to be limits on how many quotas you can hold, but if you don't know the codes, then you kind of control all the pushing anyway. Okay, listen carefully, please. We have only 10 minutes. I'm going to need everybody to help pass out papers so it goes fast, and then your curve was high in this period, which is unfortunate because a few of you did not necessarily have the highest of scores. Listen carefully. If you need to appeal, you write the word appeal, letter, circle the part of your answer where you did the right thing. If you need to stay late, I can write the pass that you, I can sign the pass that you write. Oh, or you can stay a little bit. Okay. I'll hang up the keys. There were 44 points possible because only 24 of the Scantron was graded, 1 was not. It's a mistake in the machine reading the key. I don't know which one it didn't read, but they're out of 24, not 25. You double the free response, add that to your multiple choice, and that's the total. Does anybody have any questions for me on the stuff I just said? I need these back. You don't get to leave until we count them. Abby will help me count at the front. I need a bunch of kids to pass stuff out. Ready, set, go. Pass stuff out. Come on, come on, come on. Help kids pass out, help kids pass out, help kids pass out. Grab a few, keep an eye open for the kids, look for your name on the paper, help the kids pass out. If everybody helps me, everybody gets more time. Keep all your other stuff, but I need the tests back. In this class, we accepted something like 7 appeals last time, so it's worth checking.
Is Erica here? Where's Erica? Thank you.